right, guys, so. Okay, sure. Yeah. It's nice to have you guys. No, don't come and get them. That's telling me that you're leaving. That's what that's telling me. All right, so. Yeah, why would I have a mob of people up here? That's crazy. I do not want that. So I got a question from somebody from section 13.1. So let f of x equal, the biggest mistake I see on this problem, and they said find x so that f of x equals 9. What I always have people do is they'll throw a 9 in there. Now if they wanted me to throw a 9 in there,
it means x minus 5.
Flush.
And the baby
Flush.
Thank you. Equals 9, right?
Say one more time.
9 equals x minus
Yes,
5.
good. That's the right way to do it. But if they wanted me to put a 9 here, they would have asked me what is f of 9.
Yeah.
And then that would tell me to throw a 9 in there, right? But they didn't say that. They said make f of x, and what's f of x?
X minus 5.
Yeah, make that equal 9. And then how do you solve that?
You square root.
Square root. And the minute you do that,
Plus minus.
plus or minus, good. So those go away.
Yeah. Plus minus 3. Yeah. X 5 plus minus 3.
Now if you leave it like that, I'm not going to like that.
Yeah.
Because that's sort of like telling me, now you do the work, Jeff, and you find the answers. No, it's not me doing the work.
8, 2.
I like it. 5 plus 3 is 8. 5 minus 3 is... There's your 2 answers, right? So whenever you have a plus or minus, it's telling you there are 2 answers. If that part's the square root of 3, I don't need to do this, because I can't. They wouldn't be like terms then, right? But if they are like terms, dear God, put them together. The most people we've had in a long time, we did it at one point, and then they start to teach and then we don't. I don't know. All right, so is that cool if whoever asked that? I mean, that must be because we just did it. All right. And then the other one, is this another one? Does it say, do you remember if it says solve this in a specific way? It looks like they want me to solve it using completing the square, right?
You can choose, if it doesn't say anything, you can choose whatever method you
Oh, that's
want.
what it says complete the trinomial or something.
Complete the square.
The right answer is the same room, so that's
Alright, so what are the steps to completing the square here?
You gotta cut
1
that thing in
minus
half.
6 divided
Yeah,
by
first step,
minus 6.
cut the negative 6 in half. Whatever the middle number is, as long as these are in the right order, right?
Yes.
So the middle number is negative 6, so you have to cut it in half.
3.
And then what do I do with that?
Square.
Square it. So what do I do with this 9?
In the middle, up there.
So if I put it here,
You put it in the other.
yeah, I better do it to that side
I have
too.
a question.
Sure.
So when you do this, you add it. Whatever you do on one side, you do it to the other side. But when you're finding the vertex, whatever
We'll
you
get
do.
Okay. Because what did I do here? I did it on both sides.
Yeah.
If I do it, and why do I do it on both sides? So that really I just did nothing.
Okay.
Because if I say, okay, 1 equals 1, if I add 2 to both sides, I have 3 equals 3.
Yeah.
It's just as good of a statement as 1 equals 1, right? I really haven't done anything. Yes, Jeff, 3 is 3. Good job. So, I mean, adding it to both sides is effectively not doing anything.
Okay.
So if I want to do it all to one side, I actually have to do that more directly. If I add 9, I better at the same time subtract 9. So I very obviously don't do anything, right? I just make it look different. So what does this part tell me?
Is x minus 3.
Yeah, this guy factors like x minus 3 squared. And on this side I get 19.
And then square root.
Square root it, plus or minus, add the 3 up. Cool.
I don't remember.
Is that cool?
Yeah.
No.
Is that the answer? Yeah, because...
It's not the answer. You gotta get to x.
Okay, I did it.
Did you get this far?
Yeah.
Okay, alright,
I
so.
did it and like when I'm writing the answer, it stays wrong. I tried it 2 times.
So there's a way to send me the question through email, so then I can see exactly what's wrong. Because somebody else was asking me that question, and the answer was supposed to be like 3 plus square root of 7i. But what they did, and they kept saying, they said, I'm not going to tell anybody who you are. But they thought it was the same answer when really they were doing that. Completely different answer, right? So it looks like the same answer, but no, the i's got to be outside the square root. So I don't know if that kind of thing might be happening to you. Maybe.
So when you're completing that x minus 3 squared, are you putting the square root over there?
No, so completed the square is this.
Okay.
Now I look at it with a fresh eye and I say, now I'm here, how do I solve that? You don't FOIL it back out, that'd be crazy. You kill the square more directly, right? Yeah,
Right,
so then
you do the,
square root.
and then it's just x
So it's
minus
x equals
3.
16.
Plus minus.
Plus or minus.
Negative 22.
X, no, you're, God, be careful. Square root of 19.
It's 9.
Oh,
No C shit.
you gotta move the 3
Plus
over.
the 3 root the 3. 3 plus or minus square root.
And that time I'm done because these are not like terms. I couldn't do like we did over there because they're not like terms. So I can just stop there. There's no point to go on. Now there are two answers, 3 plus square root of 19 and 3 minus square root of 19. There are two answers, but I can't put them together, so just leave it like this.
It sucks that online doesn't allow you to do that plus or minus. You have to physically write it out. It's annoying.
Yeah, you have to write it out.
Are you okay? I'm sorry.
It takes more time typing.
I just had a lot of, I don't mean anything against you. I had a lot of whiny students that I saw. So. Yes. Did you have a question? You're good? Nicole? Anybody else have a question from anything? Okay. All right. So we do have to finish out section 13:7. And I don't know if you remember from last time that, I think it was last time I told you that 13.8 was extra credit.
Yes.
And we're going to see if we could do one section out of 14. I don't know. Let's find out.
14 goes under
Jeff,
13.7.
the extra credit for the homework, does that count towards your grade score or just homework score?
What counts toward your homework score? Yeah. And to be honest, the way I do it is, at the end of the semester, if you get an 82, I don't care how much extra credit you did, you got a B. You're not going to get enough extra credit to go up to a B+. Are you with me? So then I don't even look at it. But if you're like at an 87, then let me go see if this guy did some extra credit, and then if it's enough to push you over to the B+ side, right? So homework extra credit goes directly to your homework grade, and if the new homework grade is enough to push you over to a higher grade, then I look at it. Does that make sense? Because at that point, I'm grading a lot of stuff, and if there's no reason, I'm not going to look at it, right? But if there's a possibility that you can get a higher grade, then I'll take a look and see if it's good enough to get you to that higher grade.
What if I'm doing it online though? You don't have to grade it.
Well, then I just have to go in there and look and make sure that you did enough, and it does tell me if you got it right or wrong. So if you didn't get enough right, you ain't going to get the credit.
Which is extra credit? Which chapter?
Oh. 13.8, and on the updated homework sheet, there was something I put on there too, right?
12.7.
You already put that on Blackboard, right? The extra credit?
12.7, yeah. Say again.
Did you already put that on Blackboard, 12.7?
On my math lab?
Yeah, I'm sorry.
I did. Yeah, but not everybody's on there, so they don't know. Okay, let's see. Before I get too far, anybody need? I gave out a handout that kind of goes over all the different ways. Solved by factoring, solved by square rooting, solved by completed square, solved by quadratic. Okay.
I'm sorry. You allow test corrections on the time.
What's the name of it again? Oh, okay. So don't call me up and say, can I come sit with you in your office and look over the final? No, that's the one you can't correct because it is the final. Right?
That's the most important one to correct too.
Well, and the funny thing is, students don't realize that by the time you're taking the final, how much of your grade is already set, like 75, 80%, right? So the final, even though it's the heaviest weighted test, by the time you take it, it's like 1/4 of what you've already done. Just, I don't know if you guys understand what I'm saying. So it can't, what's funny is people get from me, the final grade sheet's going to tell you what you need to make on the final to pass. And some people are going to need a 1.6 on the final to pass. Because if they make that low, their grade is high enough that they have to get that low for it to actually have an effect. Because the final is not as heavy weighted as everything else. Oh, so it's very interesting.
It is great that it's not heavy weighted because with all the information that we have in.
Yeah, I know. Yeah. Ooh, yeah. And it's cumulative.
I was thinking, yeah.
All right. So, what we got into a little bit last time for 13.7, we barely got into this, I think.
We did the graphing and the vertex.
Guys, hey. Why are we here again? All right. So if I'm given something like this, the first thing we talked about, and this was the question somebody was asking earlier, I can try to put this into this form here. And to do that, I, of course, would have to complete the square here, right? If I do this, the reason this is nice is because then I can just see the vertex. It's sort of like solving for y in a linear equation, and then I can just see the slope in the y-intercept, right? If I get a y equals mx plus b. So this kind of runs through a lot of mathematics. If you put the equation in the right form, if it's a circle equation and I put it in the right form, I can see the radius and the center. Those are the two most important parts of the circle. You guys kind of with me here? That idea of if you just put it in the right form, I can just see certain things about it. So if I had this here, let's say, let's do one that's a little freakier.
I didn't get what you did.
Say again?
First one, what is it?
Well, I'm sorry? So this is a general quadratic equation. Right. Why do we call it quadratic? Because it's got the square in there. Okay. And it's called quadratic because the square would come from a four-sided figure if you took the areas where the leaf kind of goes. So this is a general quadratic function. I can take that and put it in this form, and then I know a lot more about the graph of it. Just by looking at it, I can tell a lot about the graph. The most important point on what would this look like if I graphed it? What shape? Parabola, a U. And just about the most important point on that U shape, no matter if it opens up or down, is
the minimum, the vertex.
The vertex, the turning point, what we call the vertex. So it could be maximum if it opens down. That's like a profit function. So if you're like this, you're like, I want to be there so I get the most profit. Or turn this way, be a minimum. Okay, so a lot of this, when I want to try to graph these things, I want to try to find the most important points. Vertex would be important, Y-intercept would be important, X-intercepts would be important, all that stuff.
Can you go back over, how did that, the second one where you have A and then in parentheses X minus,
Yes,
what is that?
that's the standard form, right? Standard form. So this is what we talked about last time. We did a couple of problems like this. What would the vertex be for this?
It would be minus X minus H.
It could be H. Okay.
Okay.
Yeah, so we talked a little bit about that last time, that if I put something in here, it moves it. Mm-hmm. Right? So if I have a parabola, it's normally, if I have y equals x squared, let's make a little table of values. What's 0 squared?
1. 0, I'm sorry.
So 0 squared is 0. So there's a point there. What's 1 squared?
1.
And what's negative 1 squared?
1.
1. Good. So 1 goes to 1, negative 1 goes to 1. So y equals x squared will look like this. So it looks like a parabola, and it's sitting on 0, 0, right? What will little 0, 0 do? Getting smushed. So last time we did one that I think it was actually exactly this. I can't remember now.
Yes. Well, it was positive.
Sure.
Yeah, it was.
And what we found out was when you plug a negative 3 in, that gives you what?
The burden. The what?
What do you get when you plug a negative 3 in?
The X.
No. When you plug a negative 3 in, what do you get out?
Zero.
0. There it is. Don't try to tell me what it is. I don't know yet. So when you plug a negative 3 in, you get a 0. And it can't go any lower than that, can it? I know it can't because it's squared. The minute this is anything except 0, the answer is going to be some positive number. So that's got to be the minimum. The smallest output this could have is 0. So what really happens is when I put a number inside with the x, it moves on the x-axis in the opposite direction. So when I plug numbers in, what do I have to plug in to get 4 here? 2. I got to plug a 2 in to get 4, right? But what do I have to plug in here to get 4? This is a little bit freakier. Not to do. Negative 1. Because what's negative 1 plus 3?
4.
2. 2 squared is 4. So everything I plug in, I used to have a plug 2 in, but now I can plug negative 1 in, because the first thing I do to every number I plug in is add 3. So all my inputs can now be 3 smaller than they used to be. So this whole parabola just gets up and moves back 3. That's what this effect has. Equation-wise, when I put a plus 3 inside, okay, good. But graphically, what does that mean? It's going to get up and move back 3. So now it's going to, instead of sitting at 0, 0, it's going to sit at negative 3, 0. And then here we got negative 1 was 4. So that looks like that. So it just got up and moved over. So that's why if I can put it in this form, I can see the vertex is H. And then this would just take it up by so much. So we did several of these last time. Looks like I might want to do several more. Okay. Let me see. So, help me out here. If I have x squared plus 2. Let's plug some points in. So what do you get when you plug a negative 1 in there? 3, right? Because negative 1 squared is 1 plus 2. What do you get when you plug a 0 in there? 2. Good, because 0 plus 2 is 2. When you plug a 1 in there? 3. See, so that's the turning point. That's the low point. 3, 2, 3. You kind of with me? So if you think about it, if I square x and then add 2, the smallest that could be is 2. What's the smallest that a real number squared can be? 0. 0 squared is 0. There's no way you can get negative from a real number, right? So the lowest this thing could be is 2. I'm seeing that in my table. It goes 3, 2, and then it goes to 3 again. That's the turning point. So if I graph this thing, it'll be 0, 2, negative 1, 3, 1, 3. It looks like that. So what did the parabola do? Normally it's sitting like this. It moved up 2. Of course it did, because it's what it was plus 2. So visually, it just goes up 2. All the outputs are now 2 bigger than they were. So that's nice. When it's outside, it does exactly what it looks like it does. When it's inside, it's the opposite, because all of my x's can have to overcome that.
But when it's inside, wouldn't it be like moving to the sides instead of...
So if I had, for example, if I had this, a really good way to think of it is, how do I get 0 now? What do I have to put in? 3. I used to have to put 0 in to get 0. Now I've got to put 3 in to get 0. It moved over 3 to the right. Because all my inputs, the first thing I'm doing with those poor inputs is subtracting 3 from them. So they all have to be 3 bigger than they were before when they go in. So that's why the whole thing moves over to 3.
And then if you have another number there, so it's 0, but you can't square 0 because that's the 0.
Well, 0 squared is 0. You can square 0.
So you have, for your x, you have...
So what about 2?
2 minus 3.
Squared?
1.
1. What about 4?
1.
Yeah, 1. So it's negative, it's 3, 0, 2, 1, and 4, 1. So there's my parabola now. So once I get those 3 points, the vertex and then 2 other points, I've got the whole damn thing. I've got it pegged. Right? Just got to get those 3 anchor points is what I call them. But you see, the real thing to realize is that what happened to the shape? Normally it's here. What did the shape do? Moved up 3. What was inside though? -3. So because all my inputs now have to be 3 bigger than they used to be, because the first thing I do to the poor little things is take 3 away from them. So that's why it looks like this. It's got to go up 3. Because now to get a 0 out, I don't put 0 in, I put 3 in. Because then 3 minus 3 is 0. So that's why when I get it in this form, where would the vertex? Normally the vertex is at 0, 0. So how would it move? It would move like up H, if H is positive, and up K. So now the vertex would be at HK. That's why the vertex is HK. So if I put this in this form, the vertex just jumps out of me. It's kind of nice. Right? And that, you like it when things just kind of jump out.
Minus H squared? That's
Say again?
it's always X minus H, that's the form. It's not going to be plus H, it's always going to be
Yeah, if there's a plus inside, that means H is negative. Because maybe you went back. Right?
Alright, I just want to make sure that.
So let's do before we do that, let me do a quick fire around here. Everybody watch this. It's a tough shot. Can you tell me what the vertex is?
Jeff, somebody wanted to answer to that question?
This here? This one?
I'm thinking on the one you erased.
It's too bad. I think everything that was up there was answered.
Oh, okay.
Yeah, it was just a graphing problem. We got it graphed, right? Okay.
That would be 7, 11.
Yeah. So what would the vertex be here? 7, 11. Right?
I'm sorry, you did the 7 because it sets it to 0?
It's that simple. If it's inside with the letter, it's with the X. It's going to move it left to right. It's going to do the opposite of what it looks like. Because my inputs have to be that much bigger. It's got to overcome the -7. So it's got to become positive 7 to come out to be 0. So that's where it's sitting now. And then this makes it go up 11. So what about this guy?
-5.
-5.
-2.
-2. Kick ass.
Wait, how'd you get the -5?
Because it's
That's the opposite of what's in there. How do you make this 0?
-5.
That's the quick way to do this, yeah. And that's because if you make it 0, that's where it's sitting. Right? So to make x squared 0, it's 0. It's sitting at 0, 0. Ooh. To make this 0, it's -5. And then this would take it down 2. That's why it's at -2 now.
So is that,
Yeah.
oh, go ahead.
The little, you got it x plus 5 and it's squared. You have nothing that squares 2?
No. So for example, if I had this, and I was talking about, lines, and then somebody would ask me, well, why don't you multiply by 7, Jeff? Because you got a 1/7. I don't like fractions. Why would you look at them like they're crazy? What can you tell here that you couldn't tell if you multiply by 7? What can you tell here?
-7 is
Slope is 1/7, and the y-intercept is 0, -7. So I don't want to, if it's in the right form, I don't want to screw with it. I want to go, oh, thank you. Right? So this is in the right form. It's got to be in this form. If it's in this form, I know what the vertex is. So Carl, I could square that and all kind of stuff. I could. There's nothing that says I can't. But if I want to know what the vertex is, I'm really hurting myself. I can just see what the vertex is if I leave it here.
Why is it there then?
Because I gave it to you like that. Yeah.
So then the negative, so the 11 on the top, and then the -2, that's like your y-intercept.
It was sort of. Not really.
Okay.
What it does is, whatever that parabola is,
Up or down.
that parabola would go forward 7, and then it just takes that parabola up 11. So it does exactly what it says. Whatever that output is now 11 bigger. So that's why that one is just directly what it says. Okay. Yes?
So basically, you're going to have one of these forms written, and it's just going to ask for the vertex?
If you're lucky.
Like,
Otherwise you'll get this.
Yeah.
If it's in that form, it should be a nice thing. It's already in that form. The hard part of this problem should be getting it there.
Question. That's what I was waiting for.
I know.
Okay.
So, but first I want to make sure everybody can see
Okay.
how to read this. It's exactly like mx plus b. Even if you never understood why the number where the m is the slope, which means you didn't take me when I taught that. So I try to tell people. Even if you don't, you just accept that whatever number is there is a slope. So I've explained to you why this kind of moves. The vertex can be found by following what this would do. This would make everything go over 7 and then up 11. So that's why the vertex is here, because it normally starts at 0, 0. So if I move that over 7 and up 11, now it's at 7, 11. But even if you don't like that, if it's in this form, you just read this off. That's what the vertex is. Yeah.
But I'm just asking what the question would be to the problem. Would it be find the vertex?
Yes, could be. Or it could be just graph this. And if you're going to graph a parabola, you have to find a vertex. That's one of the most important points, is where that thing turns. Right? You got to know where that bad boy is. Okay. So, we're going to do several things with this. How do I get that into that form? What's the fundamental thing I have to do here to make it look like that?
You have to do the quadratic formula. Well, you take out the 2, right?
Not quadratic, but before that.
Well, we've been doing
Complete and square.
Yeah.
You can do.
2x. So what's not good about this 2 here? I got to get it out, right? Because complete and square only works when there's a 1 there. So the first thing I want to do is take a 2 out. I can put that nice one. So I get x squared plus 6x.
So you divide x.
So we've done this before, right? The only new thing here is it's all on one side of the equation. So that's the whole Indiana Jones thing, right? If I'm going to put some sand down, I better take the gold statue
So you
away.
need the -1 there.
If you've never seen the movie, I'm sorry. It's my favorite analogy for that. So you should go see the movie.
And now
So yeah, what are my steps?
6 divided by 2.
Yeah, half of 6 is squared.
9.
Now here's the neat thing. You ready? Here's here's the part that is difficult. If I put plus 9 there, I didn't just add 9 to the equation. I added 18. You see that? Is there really 6x in this equation? No, there's 12x, isn't there?
Yeah.
It's 2 times 6.
Is there really x squared? No, there's 2x squared.
Oh, okay.
So did I really just add 9? No, I added 18. So what do I have to do out here?
Negative 9.
Subtract 18. Alright, so if I add 5 to a number, how do I keep it the same number? I at the same time have to subtract 5 from it. Right? So if I have 7, if I add 5 to it, how do I make it stay 7? Subtract 5 from it again. Now that would be silly. And some of you guys feel the same way about that. But this has a purpose. I just did nothing to this. In fact, let's do this. This is not what you do to do this problem. You with me? But I just want to prove to you that we got the same thing sitting up here. Right? You guys with me? I'm claiming that this is the same as that. If it wasn't, I would be so full of shit. I couldn't do this. When I write this here, I am saying it's the same thing that was there. It just looks different. That's my claim. Let's see if it's true. Let's see if I am full of shit. I might be for other reasons, but not for this one. What do you get when you multiply this out?
2x squared plus 12x plus 18.
And over here I got minus 19, right?
Yeah.
So I get 2x squared plus 12x,
Minus 1.
which is what I had to begin with, right? So those are the same. Those are the exact same. And they have to be the same. So if you feel like we haven't done anything, you should feel that way when you solve any equation, because you haven't really done anything. You've just moved things around. But by moving things around, you actually see what the variable is. So by moving things around, I put 18 here, and I did minus 18 there. So I just move stuff around. But by doing that, now how do I factor this?
X
X,
plus
plus
3
3 squared.
equals minus.
That's what this one's saying.
No equals there, right?
Right.
So what's the vertex?
3, negative 3, negative 9.
There you go. Cool. All right, so let's do a couple more things to this before we go out of it. Yeah.
And do you leave that 2x squared plus x minus 1 like that? Or can we write it as 2x squared? Is that answer right there?
Here,
Yeah.
this is nothing you would ever do.
Okay.
That is me showing you that if I undo what I've done, I get back to where I was. Yeah, just proving to you that that is the same as this. And they have to be the same, or else I have a different equation. Right? So on one level, you should just get over the fact that we haven't done anything. I can't do anything. It has to be the same.
The book kind of complicates it. 'Cause
I'm
in
sure
the book-
people feel the same way about me.
No, this is way better. Because in the book,
I know.
inside the parentheses, it gives you plus 9
I know.
minus.
I know. Some people like it, but whatever. So the book has a slightly different method. You can look in there if you want to, but I think it's crazy. Okay. Okay. So really, this is not that horrible. The minute you take a number out, whatever number you put inside, it's going to multiply by. You know that. So to balance it, you got to subtract, or, if I put a minus in it, I have to add. You have to undo what you just did. So I added 18 when I put that plus 9 there. That didn't used to be there. So then I had to subtract 18 at the same time. Now, somebody help me out. Let's see. How do I find a y-intercept? How do you always find the y-intercept?
X equals 0.
Yes, never forget that. In my last math course, it was like Math 896, I defined a w-intercept. So I said all the other 50 letters equal to 0 to find the w. And I don't care what level of math you're in, it actually is the same damn thing. So to find the y-intercept, I make x 0. Now what's really cool, I can do it here, but this is much better form for that. And these are the same damn thing, aren't they?
Yeah.
So if I make x 0, what do I get?
Negative 1. 0, negative 1.
Yeah, let x equals 0. So if x is 0, I get 0 plus 0 minus 1, I get negative 1. There's my y-intercept, kick ass.
But why do you need the y-intercept?
We're going to graph it.
Okay. Instead of making the
I
little
like that reaction.
giving.
Exactly. We're getting more sophisticated than XY tables now. Right?
That's better.
Well, if you're doing an XY table, it means you don't really know much about what it is you're looking at. Because when I learn a new function, it's the first thing you do is do an XY table. But when you learn more about it, you get to places where you don't have to do an XY table. Then
I did XY table and all.
that's not good. All right. So now I know the vertex. I know the y-intercept. Now here comes the part you'll really, really love. You'll eat it up. How do I find the x-intercepts?
Maybe y0. But it's over there.
I like it. So that'd be 0 equals this. How do I solve this equation?
Negative 0, negative 1. 0.
Don't go overboard. We just learned a shortcut to...
You factor.
Quadratic formula, right? Can you factor this? Guys, if you could factor this, then I would have said yes, do that. But that you cannot factor. There are no factors negative 2 that make 12. So when you can't factor something, you do quadratic formula, right? So what do I get when I do quadratic formula?
Negative 12.
Negative e, give or take.
12 squared minus 4 times 2 times 2
C.
times 2.
4ac
Yeah, and then
over 2 times 2. I like it. Cool.
Jeff, I have a question.
Yeah.
In there, is that other words, or we just continue the line? We're still solving the same question?
we're graphing it.
Yeah, so when you graph a function, you have to find out as much about it as you can. So I need to find out its vertex in this case, and then the intercepts are always good no matter what the thing is you're trying to do. Right? If that came out complex, what do you think that means about your parabola? Let's do this first. What does this come out? Let's see, wait. So you have plus or minus square root of 144 plus 8. You guys see that, right? Is that right? So I get square root of 152 over 4. So let's see if we can just plug this in the calculator so we can get decimals. That's easier to graph, right? So somebody help me out. Negative 12 plus this over 4, negative 12 minus this over 4. What do you get? Somebody help me out.
It's 152. Minus 36.
Yikes. Let's see, negative. Yeah. Yeah, so for the second one I get negative 6.08 roughly. For the first one I get...
Negative 8.91.
Huh? Let's see, no, I can't do right. So negative 12 plus the square root of 152 divided by 4. Yeah, I get 0.08 roughly.
This is where I have problems with
Why is that?
homework. When I put, or maybe it wasn't this, but I came up with that.
So if you want to put the whole thing, yeah, exactly. You will. I mean, if they're irrational and you're supposed to graph it, then you want to get it to decimals. If you ask me to graph 4 plus the square root of 11, I'm going to look at you like, excuse me?
Yeah.
So you go ahead and approximate. You're doing it by hand, so you don't have to get a perfect answer.
Yeah, but online it was weird. I was just
It
pulling
always
up.
is.
Yeah, I was pulling it up to try to have you.
All right, so now I know the x-intercepts. I know the y-intercepts. So if I go to graph this thing, so I know it's going to hit at negative 6.08, so about right there. Positive 0.08, so like right there. Where's the vertex again?
Negative 3.
Yeah, negative 3, negative 19. So let's make this scale like 5s. Negative 5, negative 10, negative 15, negative 20. So negative 3, negative 19 is right there. So it's good. Right? And I know it opens up because the first number is positive. If that was negative, it would open down. And where's my y-intercept? 0, negative 1, so about right there. So that looks good. Lines up nice. If I do it right, there you go. Swap. And that's remarkably ugly, you, but oh well, too bad. All right. You can make it better. But those are the three things you can get: the y-intercept, the x-intercepts, and the vertex, and then you can graph that. So let's do this. A little bit of time I have left. I will give you the shortcut to finding the vertex. All right?
Finally!
It's like a long, small
So funny. So, when you learn something, I hope to God you don't just learn the shortcuts. If you do, and you become a doctor, please advertise that fact. I will stay the hell away from it. But the minute you go through a problem and you see how it works, then you can start to talk about the concepts and try to develop a shortcut. Yeah?
Where did you put 0, negative 1?
Right there. Roughly, just approximating it, yeah. Okay. So, I don't know if you remember, but last time we started with one with nice x-intercepts, and then I asked you where must the vertex be, and it had to be right in the middle of them because of the symmetry of it. All right. I want this here. Put it back. Go ahead. So, last time we looked at one like this here, sort of. So the x-intercepts would be where? Where would the x-intercepts be?
Negative 1.
Yeah, negative 1.
Negative 5.
So those are the x-intercepts. Where must the vertex be?
On the middle?
Right in the middle of the two, of course, right? Now, where did these x-intercepts come from? Where did we get those x-intercepts? Did we get it from that form? No, because we couldn't factor the damn thing. But we got it from the quadratic formula, right? Now, this is so cool if you let it be. Here's the quadratic formula. I mean, when I have it like this, I can get the x-intercepts, and then what's in the middle of negative 5 and negative 1?
Negative point. The vertex.
Negative 3. And then how would I find where the vertex is? I know the x is negative 3. How would I get the y? If I know the x is negative 3, how do I get the y?
You plug it in.
Plug it in. Exactly. Right? So it'll be negative 3 plus 1 is negative 2. So negative 3 plus 5 is 2, so it'll be negative 4. So it'll be a negative 4. Bam. I know it's got to be right in the middle of those two intercepts because it's got to be symmetric. It's got to be on the mirror in between, yes?
Can you show me how you get the negative 4 again, please?
Just plug it negative 3 in. Negative 3 plus 1 is negative 2. Negative 2 plus 5 is 2. Negative 2 times 2 is negative 4. Just plug a negative 3 in.
Or any number?
If you're talking about the x-intercepts, if you know the x-intercepts, you know the vertex is right in the middle. If you know the x piece of the vertex, I don't care where it came from, how do you get the y piece? You plug it in. You've got a function there, right? So that's how you plug it in. Alright, so here's the quadratic formula. Let me write it in a slightly different way. Let me just break it up a little bit. This is kind of cool, if you let it be. That is how I got these x-intercepts. Now, the vertex would have to be right in the middle of those two things, right? Mm-hmm. All right, now watch. Whenever I do this, I do negative b over 2a, and then I add this much, and I subtract the same amount to get the intercepts, don't I?
Yes.
So what will always be in the middle of your intercepts? Negative b over 2a. So what I'm trying to say, now watch. The shortcut to finding the vertex, if they gave me this problem, and I had to find the vertex, and I didn't say you had to do it by putting it into standard form. That's what this means. You'd have to complete the square. If I just said find a vertex, let's see if we get the same answer we got before. The x piece would be negative b over 2a. What's b? 12. What's a? 2. So what's negative 12 divided by 4? Negative 3. Right? Negative 3. That's what we got for the vertex, right? And then how do we get the y piece?
You'll go to the fx. And
you plug the negative 3 back in. That's all, right? So what's f of negative 3?
2 times 9.
Yeah.
12 times negative 3.
So you get twice 9 plus, minus 36 minus 1. You get 18 minus 36 minus 1. 18 minus 36 is negative 18. Minus 1 is negative 19. The thing we got earlier, right? Wasn't that that's negative 19?
Yes.
Right. So I know that's easier, but it's a damn shortcut. And to understand a shortcut, you have to understand the concept behind things. So the shortcut is, if I only can know the x-intercepts, and then I can get the number right in the middle. Well, I don't care what kind of x-intercepts you got. They can even be complex. This dude is always in the middle of them. So he will always be your x piece of the vertex.
Are we going to have another example or not?
No, that's it. Yeah. You should know about it. I only give one example.
Are we going to go over it again or no?
What do you think?
That's me, I'm doing good.
I understand. Of course we are. Alright, so basically I'm going to give you this. Number 4 is a problem just like what we did up here.
So I have a question that I don't know if you answer. You said...
Keep it to yourself.
What do you mean? You asked us what do you mean to get imaginary numbers in the quadratic form?
They're negative under the square root. Yeah. You get a negative under the square root, you can have a complex number. So number 4 is like the one we did up here. Unfortunately, number 6... If you guys will have a different reaction, number 6 will have to be on the next test. Because that's from chapter 14.
6 will be on the next test?
Yeah.
So this test covers chapters up to what?
Oh.
Covers what?
12.5 up through 13.7. Yeah.
Are we going to go over this on Tuesday?
Yeah. No, Thursday. Yeah, because then the test is Tuesday. Yeah. 12.5 to 13.7. So from the section that wasn't on the last test up until the last section we did, as always.
Now what's wrong?
All right.